Hello everyone, in this video I'll show you how to make a prohibited antenna that can be used to get free internet. I'll say right away that this idea isn't mine. I just found the schematics on the internet and they were called the prohibited antenna. The antenna really works, and with it you can catch a lot of access points with good speed. So, in this video, I'll explain in detail how to make this kind of antenna and how to connect it properly. So, to start, we'll need a piece of galvanized metal with a thickness from 0.3 to 0.8 m. With a compass, draw 6 circles, each 65 mm in diameter. Most importantly, all parts must be made within 1 mm accuracy as shown in the drawings, or the antenna won't work. Now we use metal shears to cut out these circles. By the way, in the antenna, these circles are correctly called patches. Drill a 3 mm hole in the center of each circle. Next, you need to take a piece of galvanized metal measuring 230 by 360 meters and drill 6 holes in it. According to the drawing you see on the screen, you'll also need some kind of plastic tube, from which you need to cut bushings 7 mm high, then with a size of... According to the instructions, the diameter of the tube should be at least 10 meters. We use sandpaper to make the bushing exactly 7 mm tall. You need to make 6 bushings like this, just like the patches. Insert a screw with a plastic washer into each patch, then place the bushing underneath to avoid contact with the reflector. Repeat for all 6 patches. I'll be screwing them in using my new screwdriver from Ugreen. This set includes all the popular types of bits, all the pieces are placed in a very convenient box, and the bits are made of good quality metal that doesn't bend or rust. The screwdriver is very convenient to use thanks to the handle that rotates, and the set also includes an extension. We screw the patches onto the reflector, which is a large sheet of galvanized metal. The screwdriver is high quality and the bit doesn't bend. Now all the round pieces are patches. You need to connect them using copper wire with a cross section of 4 square millimeters, which by the way is also an important size. You need to solder the wire in the center of the circle. To be continued. That's it, I did it. Next, use the same gauge wire to make a special jumper, 121 mm long plus 5 mm on each end for soldering, totaling 131 mm. To bend it correctly, you need to make a special jig. On a piece of board, you need to mark 2.78 mm apart from each other. Now drill a hole with a thin drill bit, and then with a 10 mm drill bit. 10 mm is also an important size. According to the instructions, insert a 10 mm drill bit into the holes. Now we take our wire, place it in the center, and bend it as shown in the video. It's very important here that the bend radius is 10 mm and the distance between the bends is 78 mm. This is the kind of jumper we got. Now using it, we need to connect the first and second rows of patches. The final piece to cut is a strip 11.8 mm wide and about 100 mm long. Mark 66 mm from the edge of the strip and make a bend. From the other edge of the strip, you need to drill a hole. We place the strip against the crossbar and through the hole, mark the reflector according to the marking. We drill a hole with a thin drill bit and then with a 10 mm bit. We screw the antenna cable connector into the holes we drilled. Now we place this strip exactly in the center of the crossbar and put a 4 mm drill bit underneath it, meaning it should be soldered at a height of 4 mm from the reflector. One end of the strip is soldered to the crossbar and the other to the central contact of the connector. Only after that the drill bit is removed and the excess part of the strip near the crossbar is cut off. At this stage the antenna is finished. If you follow all the dimensions exactly as I specified, it will work perfectly. To make the case, I used plastic paneling and an angle piece from a hardware store. Glue everything securely and seal all joints with sealant to keep water off the antenna. Another key point is that not all plastics are suitable for making the case. It must be radio transparent. If you use a different kind of plastic, the antenna will have a very weak reception signal. To check if the plastic is radio transparent, you need to put it in a microwave. If it doesn't melt, then it's suitable for making the case. Off camera, I drilled 2 more holes in the reflector to attach the antenna to the case. Using a soldering iron, I make a hole and then fasten it with M6 bolts. I took longer ones so that I could attach some kind of bracket to them, so that the antenna could later be mounted on a mast. I made the case cover from plexiglass. It is also radio transparent, not because it's see-through, but simply because it lets radio waves pass through. I also glue it on after sealing all the joints with sealant. This is the kind of wonderful case I ended up with. To connect the antenna to a computer or laptop, you'll need any Wi-Fi module. We remove the cap and see that inside there's a piece of wire with insulation. You need to solder the central core of the antenna cable to this wire. The braid needs to be soldered to the brass insert. We put on the heat shrink tubing and screw the F connector onto the other end of the cable. That's it. Now we connect this cable to our antenna and move on to testing it. Currently, I set the antenna on a 1.6 meter high tripod. As you can see, the laptop detects 2 access points, and one of them is mine. Now let's connect our antenna and see what happens. As you can see, everything works perfectly. I'm far from the city, but nevertheless the antenna picked up a lot of access points. We disconnect the antenna and it still gets only 2. As you can see, there are even access points without a password. But how do you hack Wi-Fi? There is a lot of information about this on the internet. Who liked this do-it-yourself project? Give this video a like and share it with your friends. Thank you all for watching and goodbye.